the weather. Anytime you have something as historically unusual as this 2011 drought was, there's a lot of factors working in concert. And about all we can say right now going forward is that we should be dry, relatively dry the rest of the winter time and even into the spring, and of course summer is going to be hard to make up for a drought. So it's looking like a 2-year drought with the possibility of extension. It's been about 40, 50, 60 years since we've had such a serious drought in Texas that has threatened water supplies. And just recently, the first small community in Texas ran out of water. They started trucking in water. We have had drought contingency plans in place since the mid-90s. And this is probably the first time that most parts of the state will actually find out if those plans work. So hopefully this won't be worse than the drought on record, but it'll at least give us a dry run, as it were, so that we know what's working and what isn't working, and we can better prepare ourselves for the next drought when it comes. Thank you. I'll be happy to answer questions. Yes. And we have, by the way, we have microphones scattered around so people can hear what you ask and get recorded.
There's much controversy now about mankind today is changing this weather pattern, you know. And Governor Perry said, no, it ain't, you know. Some people say, yes, it is. So what's the climatological take on this? We running too many cars and too much carbon dioxide, or what?
Well, let's see, I mentioned a few of the factors that do affect climate. Carbon dioxide and other greenhouse gases. They have a warming impact, which we can unfortunately quantify only within about a factor of 2 or 3. Particles that come from power generation, from coal burning, tend to have a cooling effect, which helps a little bit counterbalance the effect of the greenhouse gases. And then you've got land use changes, which affect the temperature locally primarily. That's the urbanization and clearing of forests. And then all the natural stuff, such as volcanoes and solar radiation and so forth. Bottom line with all of it is that of all of the factors that can possibly affect the climate to a large extent, the greenhouse gases are the only ones that have had the right magnitude of increase to cause the global climate to warm as much as it has during the past few decades. And in fact, the sun has been fairly constant. Volcanic activity has been fairly constant. So it's a pretty good match between what the scientists think ought to be happening and what is actually happening. So that's why the IPCC says that the greenhouse gases have apparently caused most of the observed warming. And that's going to happen for the foreseeable future. Whether that means that we're driving too many cars and so forth involves a whole host of other questions, such as how much does it cost to reduce greenhouse gas emissions? How much is it worth it to reduce them substantially compared to potential costs to society and so forth? How big a change of climate is tolerable without having to worry about doing much? And you can pretty well make a whole semester worth of lectures out of that issue. I do wish that we would get beyond the issue of whether greenhouse gases affect the climate, because there's no question scientifically that they do. It's time to worry about the whether and what we should do about it, rather than whether there's something we have to worry about in the first place. Yes?
Would you care to elaborate on upper atmosphere seeding of the atmosphere that the government is involved in, as well as very powerful pinpointed radio signals, and how that affects our weather here as they use it to experiment with war times or where a war is going on?
Sure. The question was about the effect of high altitude cloud seeding or a high energy pinpoint radiation beams by the government and how they might affect local weather. First one, there's no evidence that I know of that the government is actively involved in trying to affect the climate through contrails. Contrails themselves do affect the climate because they produce condensation, so they block some solar radiation. So they have a barely discernible cooling effect that's been fairly well documented. The bigger effect on clouds has come basically inadvertently through the fact that almost everything we do from clearing land through generating power through driving on roads produces more dust and particles than any number of planes can produce. And that's going on continuously, and it's affecting the amount of rainfall and the distribution of rainfall. And the net effect of all of that on clouds and rain and climate is the biggest unknown aspect of climate science right now, because it involves such a range of scales, from the smallest cloud particle to the global circulation. So, first part, the government doesn't seem to be doing anything with contrails, and number two, if they did, it would make a difference compared to what the rest of society is doing about it. In terms of high-altitude radio signals, there is a program to basically modify the ionosphere, which is about 50 to 100 kilometers above the Earth's surface, which is utilized for global communications. Radio waves can bounce back from the ionosphere. However, the disruptions at that altitude don't seem to have any effect on anything going on way down at the ground. And I imagine if a connection were established, we would want to stop it as quickly as possible. But it's very difficult for something up there to have an effect down here without any mechanism of energy transfer. And no known way of transferring energy back down to the Earth exists. Yes, sir.
There seems to be a lot of planning for what happens if there is a drought, the drought preparedness. What do we do if there is a drought, and how do we manage the water situation? Is there any planning done for what we can do before the drought so that it lessens the impact when there is a drought?
The question is, we talk a lot about water planning and dealing with a drought during a drought. What about what can we do before there's a drought? There's a lot of planning that goes on a regular basis statewide. Every 5 years, the state comes out with a new water plan, and regions and locality within the state come up with their own plans that go into the statewide plan, and they deal with what water needs we have going forward for the next 50 years. And everything is laid out. Here's how much water we need. Here's what we can do to solve it. The only problem is there's no money to fund any of what's necessary. And there basically hasn't been much investment since the early 1980s in water supply across the state. And right now the price tag associated with everything in the plan is in excess of $50 billion. So you can contribute as you leave the auditorium. If you get $50 billion, we'll solve the water problem in the state. Now there's of course, that $50 billion isn't written in stone. There's dispute about whether we really need all the water we say we do. And of course, there's conserving water is a lot cheaper than finding new sources of water. So maybe there are ways of adjusting that balance. But the need for investment in water supply is never urgent until it's too late for it. And it's hard to get out of that cycle in a political climate when people are elected for 4 years and then leave office. But there is in fact a diagram that makes the rounds of water planners. It's called the hydro-illogical cycle, which goes from blissful ignorance to dryness to concern to desperation, and then a little bit of rain and blissful ignorance returns again. I hope during this drought it's not so severe to cause major problems, but as people have considered the possibility of a multi-year drought, and I'd say maybe about we have a 1 in 5 chance of this being, say, a 5-year drought statewide. And you're fine up to a point, and then you suddenly hit the point where you start having serious economic impacts, not just farming and ranching, which happens right off the bat, but energy generation, industrial supplies of water, and suddenly Texas if it's viewed as a state which doesn't have enough water to meet demand, starts becoming less desirable for businesses to locate here. So the best thing we can do for our economic future, I think, is to make sure that we have a water future that's secure. Yes.
Have you done stuff?
I'm sorry. I promised the person in the back.
Mine also has to do with water supply. My question is, because frequently there is talk about, pumping water from here to the Dallas area to water their yards. I'm wondering, if, given what you said this year, the idea that the lack of water actually increased our temperature, is there some reason that we should or shouldn't take water from one place and put it somewhere else?
So the question is are there consequences of transporting water across river basins, for example? Of course, one obvious consequence which they're dealing with in the Dallas area is the zebra mussel, I think it is, and why they can't get water out of Lake Texoma because it might cause invasive species to spread. So that's one concern. That's a concern for the receiving location. For the sending location, the main thing I think to worry about is to make sure that the needs of the locality are put first. Obviously, Dallas, Fort Worth has a much bigger population, and there's a tendency when water gets scarce to go to the person with the biggest need, right, and perhaps try to adjust the balance of distribution. So it has to be done on a careful basis. I'll also mention the water is simultaneously the most valuable resource we have and the cheapest resource. And one excellent way of enforcing conservation is by having water be more expensive. There's talk that the ideal way of pricing water would be to have some base low value for household use, which covers minimum needs, and then have a second higher price kick in, which would allow for more conservation. And of course, you still want to have water fairly inexpensive for farmers and ranchers because they're providing the food that we eat and so forth. But these are all very good questions to ask and very good issues to deal with, and it shouldn't be dealt with on a piecemeal basis, such as, okay, let's try this or let's try that, but in the context of an integrated plan, it includes not just one region, but the whole state. Yeah, sorry, back to you.
Your presentation tonight has dwelt on surface water for principle. Have you done research, or have people in your area done research on the effect on aquifers and the future of aquifers in our water use?
The question is on the future of aquifers. I haven't done a lot of work on that. The good thing about aquifers compared to surface water is the evaporation doesn't have as big an effect. And so rising temperatures aren't as big a concern for places which receive their water primarily from groundwater rather than surface water. They could, though, be two different chemical constituents because groundwater is subject to a completely different set of laws than surface water is. And it's essentially groundwater is, you can think of it as being treated like oil, in the sense that if it's down there and you can get it, you can use it unless there's some regional agreement that's monitoring the total use and so forth. It's hard to generalize the effects of drought on aquifers and perhaps long-term depletion because each aquifer is different. Some recharge very quickly because they receive rain readily from when it falls on the ground. Some are maybe deeper and recharge relatively slowly. The Everett aquifer is one extreme where it's almost like this underground reservoir that can fill it up in 2 months. And then the Ogallala aquifer in West Texas has been sitting there for thousands of years, and they're gradually watching the water levels go down and down with no hope of recharge. So it's very much location dependent, and it's very much different from surface water as well. So it's a good question, and my short answer is no. I haven't got that in detail. But maybe someone else who talks here can in the series. Yes?
From what I've seen on the charts, the states directly around us are very, very hot and dry. Do you think that we're going to affect it negatively and
Okay, so the question was, looking at the drought chart, the states around us are experiencing drought as well. Does what happens to us affect the other states and vice versa? Certainly what happened in the summertime, the winds typically blow from south to north. So if you have drought in one location, that heats up the air, which then gets carried to another location. So that's why Dallas, Fort Worth, even though it wasn't as dry as the rest of the state, still had near record high temperatures. They were getting the hot air from Central and South Texas. And likewise, there were times during the summer when the hot air that formed throughout the southern United States was blown up into the Midwest and produced some major heat waves there. And those parts of the United States discovered what we had known all along, that it was hot this year. In addition to the heat, there can be impacts on air quality as pollution is emitted in one location, blow someplace else. It works both ways, of course. We get our dirty air from the Ohio River Valley, and in turn, the Ohio River Valley gets dirty air from us. And so everybody likes to point fingers. But yeah, it's all very much interconnected. Yes, sir. Okay, somewhere up there. In the shadows, no one can tell. Sorry. What's the question?
Coal mining and the gas well drilling, does that have an effect on underground water supply?
The question was coal mining
Yeah, coal mining and the natural gas well.
and natural gas fracking. Okay. Does it have an effect on groundwater supplies? Coal mining, I do not know. I haven't looked at that in detail. Natural gas, it depends upon the particular formation that's being used and how far below ground it is. Most of them, as far as I know, are well below the level at which aquifers are being utilized for water supply, but not all. And so that question needs to be addressed on a well-by-well basis.
Can you speak to the cross-state pollution issue that the federal government is addressing, the science behind it?
Let's see. To some extent I can. I've done a lot of work on air pollution meteorology, mainly focused on Houston, Texas, but also the Dallas-Fort Worth area. And of course, the major problem with ozone and sulfur dioxide is generally during the summertime, because that's when the greatest amount of power generation takes place. That's when the chemical reactions are most rapid because the air is hot enough. And the prevailing winds during the summertime, we have a Bermuda high sitting out over the Atlantic Ocean. The wind blows up from the Gulf of Mexico across Texas and then over into the eastern United States. And so the air pollution problem is really a regional problem for that, because of that. And it's starting to become perhaps an international problem because we get some pollution making it all the way across from China these days, but not as much as we generate. The problem with this is of course not an official position, this is an observer. The problem I see with air quality regulations, particularly in the case of ozone, is that we've made several assumptions which are contradictory. First assumption is we at a bare minimum we want to have air that is safe to breathe. And the second assumption is because that's a bare minimum, it doesn't matter how much it costs to have that, that's what we need. And in principle, that's fine, except what we're learning about ozone is that there doesn't seem to be a minimum safe value. They play around with the numbers of 75 parts per billion, 65 parts per million. It's all part of a continuum. It doesn't seem to be a safe value that we can say, okay, below this we're definitely safe. And then you combine that with the fact that there's a natural background level of ozone that's always present. So that, in principle, natural air isn't perfectly safe to breathe either. and put that together, you realize there's no possible target that would satisfy the requirements that we specified. And so I think agencies are doing the best they can with a set of laws that was put in place 40 years ago when it seemed like all this would be possible. And it needs to be rethought because of the complexity of larger scale transport, international issues, and the possibility that we actually have to figure out what the trade-off needs to be. I'll close with one last anecdote. I asked my introductory atmospheric science class at one time about this trade-off. How should we weigh the value of clean air versus the economic cost to obtain clean air? And I expected people to come in on a range of opinions, and everybody said, no, we want clean air. That's it. And I think politically, either you can say clean air, friendly economy, and go for those goals. And somewhere in the middle, beyond the sound bites, is the tough decisions and compromises that society eventually has to make, not just for clean air, but for water supply and all the major environmental problems that we're dealing with on a daily basis. Thank you.
When we first contacted Dr. Nelson Gammon, he kind of joked and he said, well, there's one thing that I'll do. I'll bring some good information and I'll bring some bad information. One thing I don't think we can argue with tonight is he's brought a lot of information. And as we move forward in this series, I hope you will recognize that we're going to try and discern that information, and one way you can help us in moving forward with that is to complete the survey, which is listed on the back of your program. We'd be ever so grateful if you would do that. That would help us, and in turn, as Dr. Johnson said earlier, we are here to serve you and would help us to serve you better in that manner. I hope you will agree with me that it's been an honor to have Dr. Nelson Gammon here this evening. I wish you safe travels and a good night. Thank you all for being here.